Okay, so we're looking at a formative quiz on networks. This is for the final exam. So let's have a look. So the first question is, which of the following is the row reduced? Okay, with a pen. So row reduced, and the next one is column reduced, but we have to have this answer right before we can move on to this answer. So this is a preamble before we get to the Hungarian algorithm later on. Okay, algorithm. Okay, so rows are this way. So you're just looking to find the smallest number in each of the rows. So 6, 2, 2, and 7, and then you subtract. So I want you to have a go, and when you're ready, come back. Okay, you would have found C. If you subtract 6, you get that answer. If you subtract 2, you subtract 2, and if you subtract 7, you get that answer. So you must then use this answer to get the column. So the only column we're worried about is this one here, because all the other columns have got zeros. So have a go at that one. Okay, so in that is the smallest number, and that will be the column that's going to be reduced. You don't touch these columns here, which already have zeros. Okay, come across when you're ready. Okay, this next one's a bipartite graph, and this question is about what's not true. So go through the statements, look at the diagram, and work out which one's right. Pause, and then come back when you're ready. Okay, so the only one that's not true is this one, because Melbourne has 3 and Brisbane has 1, so it's not twice as many. Okay, all the rest are true. Okay, come across when you're ready. Okay, so this is one of the meaty questions. Okay, so I've already started doing some of it. I've done the table, so we have to produce an activities table, and then we'll do a forward scan, a backward scan, and then work out some float times. Okay, so the first thing we need to do is, like, I've done this table already. I'm just trying to get my notes up again. Okay, so we've got 3, 4, 6, 7, 8, 5, 12, 2, 11, 10, 3, 9, 6. So that's not hard. Let's just pull the numbers across, and then looking at the predecessors, A, B, and C have no predecessor. So what I'll do is I'll give you some time, just pause, and when you're ready, come back, and we'll finish off the rest of this for the... Now you can't do this part here yet, because we're going to fill in this diagram first. So just do the predecessors, and then come back. Okay, predecessors are A, B, B, C, C, D, and E, F, G, and M, H, J, K, and L. Okay, so what we need to do is we need to draw our little houses. So down, little houses. I think I've got all the houses right. Okay, so we're going to do a forward scan. So we've got to pick the numbers. So it starts at 0, and it's going to be 0 when we do a backward scan. So that's a 3. Now, at the moment, we put a 10 there, but there's 2 ways. So that's a 4. 4 plus 8 is 12. 12 beats 10, so 12 goes in. 4 plus 5 is 9, so we can do that. That's a 6. That's an 8. We've got a 17 there, and a 6 plus 12 is 18, so we put 18, so 17 is too small. We've got 12 and 11 is 23. 9 plus 10 is 19, so that's no good. 18 plus 3 is 21, so 23 goes there. 23 plus 26 is 29. So that's the forward scanning. The earliest finishing time is 29 minutes. And then we go backwards. So 29 is the end. 29 minus 6 is 23, so that's on the critical path. Okay, 23 minus 3 is 20. 20 minus 9 is 11. Now, 11 minus 2 is 9. 20 minus 12 is 8, so we put the bigger number. Okay, there's 2 numbers there. Going backwards, 23 minus 10 is 13, so 13 can go there. 13 minus 5 is 8, but 12 minus 8 is 4, so 4 is on the critical path. Okay, so 23 minus 11 is 12, so that's on the critical path. 12 minus 7 is 5, so that's not on the critical path. And I think we got all the numbers. So the critical path will be there. So we're looking for numbers in the same box. There, there, and there. So that's the critical path. Critical path is B, E, J, and N. Okay? So that's the critical path. So we've completed the forward scan and hence determined the earliest completing time. The earliest completing time is 29 minutes. Okay, now we've done the backward scan, which is those numbers. So what you need to do is earliest start time, earliest finish time. So start at the top of the box, bottom of the box, and the float time, EFT minus EST minus the time. So that's the floats. Okay, so have a go and see what you get in those boxes there. Okay, this is my answer: 0, 0, 0, 3, 4, 4, 6, 6, 12, 9, 18, 8, 23. That comes from the top of the houses and then looking at the bottoms: 5, 4, 8, 12, 12, 13, 20, 11, 23, 23, 23, 20, and 29. And using that formula, so just remember anything on the critical path, B, E, J, and N, there is no float time. B, E, J, and N. So they're all on the float times. And everything else is just using this time, EFT minus EST minus the time. So we have 2, 0, 2, 2, 0, 4, 2, 3, 0, 2, 3, 0, 4, 2, 3, and 0. Okay, so expect one of those questions in the test. Okay, come across. Okay, so this is a flow, and you have to draw this one. Draw from the following, produce a network flow diagram, and then do the minimum cut and then the maximum flow. So the minimum cut equals the maximum flow. But we've got to get our diagram right. Okay, so have a go. When you're ready, come back. Okay, A to B to C. So A goes to B, A goes to C. So A goes to B. B can go to C, which is that path. B can go to D. C can go to D. C can go to E. D and E both feed to F, so that's going to be the sink. So the source is A, and the sink is F. Okay, so we put the flows in. So we've got 13, 6, 4, 10, 3, 14, 15, 10. Okay, so we finished the diagram. Show the minimum flow. So we're looking for a cut that stops the source to the sink, and the minimum cut would be just there. That's the smallest cut, which will be 19. Okay. Every other cut that you could do, like for instance, that cut there is 21. Every other cut doesn't equal as low as 19. Okay. And that will be the maximum flow. Come across. Okay, so now we have a question that's quite involved, and these numbers here we have to transform into a minimization problem first of all, because they're not the numbers we're going to use, because this is, for instance, Annie, Beth is the number one person, so these aren't the high numbers. We actually got to transfer these into low numbers. Okay, so that's the first part, convert into a minimization, then we do a row, then we do a column, then we do the Hungarian, and then we finish with the problem. Okay, so have a go. When you're ready, come back. Okay, A, B, C, D. We've got vault, uneven, beam, and floor. Okay, so we subtract these numbers from 10 because that's the top score. So we've got 5, 3, 5, 1, 4, 0, 0, 3, 3, 5, 7, 2, 3, 2, 2, 1. Okay, so for instance, this means that Beth is really good at uneven, so that's most likely where we're gonna allocate her, for instance. Okay, so that's the first part, and then have a go. If you haven't already had a go at the row and the column, so you need to be able to do that. Okay, so for the row, we're going to subtract the lowest number. So the lowest number, and the lowest number. So the row, I won't bother putting the headings. 4, 2, 4, 0, 4, 0, 0, 3, so that didn't change. Lowest number is 2, so it's 1, 3, 5, 0, 2, 1, 1, 0. So the reason we have to do a column reduction is because we've got this column of numbers here. The smallest numbers are 1, so it's going to end up being 3, 3, 0, 1, and then these other columns don't have to change. Okay, so that's the column reduction, and that's that one there. Now we have to apply the Hungarian algorithm. So in Hungarian, we have to make sure we've got 4 jobs, so we need 4 lines. So covering 1, 2, 3. So I've got 3 lines and I've got 4 jobs, so I have to apply the Hungarian. Okay, so in the Hungarian, we'll look for the smallest number not covered, which is a 1, and then we apply that number to all the numbers not covered. Okay, so the smallest numbers are 1, and we apply that number, apply that to the covered numbers, not the uncovered. We apply that to the covered numbers, and then we apply that twice. So we end up with 3. So this is Hungarian. So applying it 3, 2, 4, 1, 4, 1, 1, 5, because it's got 2 crosses. 1, 4, 6, 1, 1, 1, 1, 1. So that's the first thing. And now we do subtract the smallest number from all the numbers. So the smallest numbers are 1, so that's the first step. So we subtract it, we end up 2, 1, 3, 0, 3, 0, 0, 4, 0, 3, 3, 1, 0, 0, 0, 0. So then we apply our line test again. So 1, 2, 3, 4. Okay, so now we have the algorithm. We've got 4 lines and 4 jobs. So we've got we have to give this person this job because that's the only 0 in that row. We have to give the person that job because that's the only 0 in that row. And these two are both equal. So like that has already been used. These have both got 0, so it doesn't matter who I give the job to. So A, B, C, D, and the jobs were vaults, uneven, beam, and floor. So D definitely gets the vaults, and A definitely gets the floor, but B can either get uneven or the beam, and C gets the D. So D, no, that should be C up there. C gets the vaults, A gets the floor, and then D gets the opposite of those guys, the beam or the uneven. It doesn't matter for those last 2 jobs. So sorry about first up. So C C was the only one with the 0 in that cop there, so C has to go first, A has to go second, or vice versa, and then these two, those and those can be transferred. Okay, come across. Okay, so this is the shortest path algorithm, so we've just got a few of these to practice. Again, you've got to use Prim's algorithm. Alright, have a go. When you're ready, come back. Okay, so we're looking for the smallest path, and the smallest path is at 12. From the 12, the smallest number, the 15, 19, 13, so 13 is the next. After that, the 15 is the next, and then we've got 21, 23, 19, or we've got an 18, so I'm going to take the 18, and then I'll take the 11, so I finish that side of the network. Okay, so I've got G and F, I've got 21 and 23, so take the 21. I've got 23, can't do that because that connects to G, that's a loop. 31, 23, 44, so take the 23. Once I've got the 23, I have to take the 15. And then I've got 44, 45, and I have to take the 44. And then 45, 27, take the 27. Find the shortest path, then it's all those numbers, so it's, it's shortest path is 15, 23, 44, 27, 21, 12, 15, 13, 18, and 11. So whatever those numbers add up to, that's the shortest path. Okay, come across. Okay, we're going to finish off with two more minimum spanning trees. So you just use Prim's algorithm and it should be fine. Okay, smallest number is a 1. After the 1, I've got a 3, a 2, a 5, so I'll take the 2. After that, I've got a 3, a 4, a 5, so I'm going to take the 3. After the 3, I've got a 4, a 2, so I'm going to take the 2. After the 2, I'm not going to use the 4 because that creates a loop, forget that. After the 2, I've got a 5 and a 5, it does not matter. Okay, it doesn't matter, so I can take that. I could have taken that, it doesn't matter. I've got a 4, then I've got the 7, then I've got the 8. Okay, and then I just add up those numbers, alright? Whatever those numbers add up to is the shortest path. And having got the second one, we've got a 7, and I've got 14, 12, 23, 17, so I've got to take the 12. I can't take the 23 anymore because that creates a loop. I can take the 9. Next. Okay, I can't use the 14 because that creates a loop. I've got 16 or 17, I'll take the 16. I've got 11, I've got 17, I'll take the 11. I've got 28, I've got 17, I'll take the 17. And I've got 14 to finish. Okay, and whatever that shortest path is, that's the answer. Okay, that is it. Bye.